Good afternoon, everybody. We just wait 5 minutes, as today we have a collision between ending the honors presentation for the honors student and this the Geotalk. So we allow the staff member to move from the honors class here. So 5 minutes and then we will start. Thank you. Good afternoon, everybody. The guest for our Geotalk today is James Roberts, that at the moment is associate professor and head of the department in the University of Pretoria. He has been in the University of Pretoria for 16 years, so quite a bit. But he has, although he looks young, he looks like he worked before in, yeah, he was busy in the South African Police Forensic Laboratory from 2006 and 2007. That he was working on gold fingerprinting. And this was already a project he started beforehand when he was working in the Anglo-American research laboratories. So although his main research focus are in igneous petrology, and that's his training, he is intrigued by this use of geological tools for forensic and studies. And this is why today he's going to give us some insight about this field of how to use geochemistry actually for forensic studies. Thank you, James. This is for you.
Thank you very much. I have to say, I arrived in this department in 2001, so it's been a long time. All right. Okay. So what I'm going to speak to you today is a field that I got into very much by accident. But I first need to pay tribute to Roger Dixon. He was my employer at Police Forensics. He became my employee at the University of Pretoria He was my PhD student, he was my colleague, and he was a very good friend. And Roger had many things, and he did, but he had moved over from the Council of Geosciences into police forensics and ran their material sciences division. And he was the person I worked under when I was doing forensics. Now, if you look at the textbook definition of forensic geology, it goes into a whole load of chats about mud. You know, most of it's the online examples are how to match the mud from tires to boots to anything else like that. However, if you haven't noticed, we're not necessarily the wettest place in the world. So much of the work I'm going to talk about probably more falls into the field of material science than just the textbook example of forensic geology. The word forensic, a lot of people see it as fancy or different, but it simply means legal. All right. One of the things you got to realize if you're doing any sort of forensic work is that there is a higher degree of certainty you need to have. I mean, if you're going to testify that X meant this, you better be damn sure. Right? And the other thing that comes across, and I've always found, is the fact that you actually have to realize that your audience is very, very different. You're dealing with judges, you're dealing with lawyers, you're dealing with people, and you've got to make sure the science is very clear, right? And so on. And what we're doing, good general knowledge, some chemistry, some mineralogy, and a fair bit of stats. I even had to do some coding at times. I've forgotten everything I knew about that. All right, so I sort of wove in and out of this by accident. When I was working for Anglo Gold Ashanti straight out of university, I ended up doing a stint at Anglo American Research Labs, and I spent a Christmas with a desk completely piled up with gold. And what many people don't realize is gold is actually very variable. You don't see it. If you see a gold ring or this and that, you don't notice it. But when you have a desk full of gold, you've got green gold and orange gold and reddish gold and plainer gold and yellow and all of that. And so what I was doing there was sticking them in the laser and completing a database project there. And then a couple of years later, when I was finishing up my PhD, Roger made me an offer to come up and work at police forensics, pretty much doing the same thing I'd been doing 5 years before at Anglo American Research Labs. Because the police had taken on what they called the gold fingerprinting project back into the police. I was paid for by Goldfield Security and loaned to the police, which was an interesting way of doing things. I was a police reservist class C. So that's the same sort of category as the guys who pilot helicopters and so on. I didn't get to do any of that though.
Did you get a uniform?
Nope. They didn't even give me a gun. Yeah, and so on. So I worked there for a year and a half, then moving over to University of Pretoria. I kept some things going. So what I was doing in the main is dealing with mining and mining material, right? The biggest thing, a lot of what I'm going to say here is stuff you probably all know, but we'll look at it in different ways. So we know that mining takes the commodity out of the earth. We're geologists, we know that much. But we tend to forget that there's a level of processing and all the rest of it, and we sometimes ignore some of the other issues that come with it. And when you're dealing with theft, you've got to think about it as a long value chain, and theft can occur at different times. For instance, I'm going to mention gold. The theft tends to come in at the bottom level where you steal almost raw material, whereas in platinum, you never steal raw material, simply because there's not enough value in the raw material. You're rather going to go for processed material and so on, okay? And I predominantly worked in gold, but we did a certain amount of PGEs. We also had, I looked at coal, not very nice, but trying to figure out what goes on with coal. And then we talked about manganese and chromite and other things. And there are other odd things that came up as we went. And since then, I've been asked to do other work for various people, all right? This is the Wits gold fields. even though it doesn't produce an enormous amount of the world's gold anymore, it's about 3% in 2022. Over the course of human history, over the 140 odd years that we've known about it, it's produced a vast majority of the world's gold. Because gold doesn't exactly wear out. We produce this and it accumulates and accumulates and accumulates. But we do have, say, from 1882 to 2023, it's a long period. We have a long history of mining in there, and there's still a lot of mining activity. Even though we don't mine as much as we used to, you can see there, this is what it was like in the 1970s. You can just see that the sheer bulk of it was mined primarily from South Africa. And now that is what Africa accounts for later on. But we have a very long-standing mining history. Mining is not particularly evolved greatly. If you go underground today, it looks very similar to going underground in 1920. All right, scarily enough. You still go underground, they still use pneumatic drills. I've seen drills down there stamped with 1935 on the drill plate. All right, they don't change. All right, it's a rough game down there, and they're mining a conglomerate. And then obviously this is what they intend to produce at the far end. Though we're very familiar with things like the jewelry and some of the other items in there, there are things like this, which are actually a very high demand for both in China and India for dowries. Little Chinese gold little gold bars. That's how dowries are paid. Of course, the vast majority of gold sits in bank vaults. All right, it never goes anywhere. It gets electronically traded around, but that's not the stuff we're talking about today. All right. So, theft. I mean, everybody reads about the zama-zamas. All right, everybody knows about illegal theft, but there are a number of things you have to think about that you might not know about it. All right. So we all know that the zama-zamas, the illegal miners, go underground, old workings or even current workings. There's always somebody swiping in. There's a whole set of syndicates to get people underground, to feed them, to get food to them, and to transport material backwards and forwards. And there's also a whole lot of intelligence that goes with this. These guys know where the high value reefs are. They will go in and do what we call steal the eyes of the mine, which means they basically will concentrate on the bottom 5 centimeters of a gold conglomerate, because there in the carbon is where most of the value sits. If you're mining, you take out the entire set, the entire slope up to a point, you get your mining height and all the rest of it. But the pirate miners don't have to worry about that. They can just skim down the bottom and take the high grade stuff. All right. And where I was working in Pre-State, the old FSG shafts, we were running up to 140 grams per ton over the bottom 5 centimeters. So that is where a lot of the value sits. Even in today, the carbon leader is very rich, often up to 50, 60 grams per ton, if not higher. But of course, it's literally probably as thick as my hand in many places. So those are where the illegal miners go down and do. So that's one part. Then we get all the theft that comes out of the mills. You steal concentrate. It's already more processed. You can get a lot more value out of it. So there's a large amount of theft that comes out of the plants. And obviously, once it's refined and it is actually what we call doré, gold, or bullion, it's a prime target, right? But one of the things that people don't realize is that it doesn't matter how and where you steal the gold, you still have to actually repatriate it into the legal system, all right? And to a very large degree, that comes via jewelry, pawnbrokers. Somebody has a manufacturing license, all right? These are people who have a license to smelt down old gold, family heirlooms and things like that, and to either make it, what they're supposed to do is smelt it down and then exchange it with Rand refineries for new gold, but they obviously mix in, and there are various different things. but those are the points at which we actually get the value back in. Scarily enough, many of the times these pawnbrokers probably don't make a lot of money from the stolen gold. It's not noticeably cheaper by the time it gets to them than it would be if you'd actually gone and bought it off rand refineries. However, it is an item that you now have that you're supposed to have got through legal chains. So what they do is write up a bill of sale and claim back their 15% VAT. All right. And that is their main source of income from stolen gold, scarily enough. VAT fraud, VAT fraud, stealing from you and me. All right. So talking about what goes on underground, these are the guys that are often caught in police operations. They're often bearing material. As I said, I've talked a lot about it already. You can see guys living down there. They apparently did live down there for months in some cases, right? And they even process the ore underground. They will take the ore off the face. They will tumble it in barrels along with any sort of stolen material they can to crush it up. And then they will use mercury to amalgamate it underground, right? And then they use a blowtorch to volatilize the mercury, and that final product is what goes up to surface. Okay. Sometimes they do it differently. This is a plant that was found in the East Rand. They were supposed to be reworking the mine dumps, but were actually taking illegal material straight off the Zamazamas and processing it all in there in one of the old plants like that. And pretty much everything that was seized here had come off the mines and been stolen off the different mines there for this processing plant. There you go. I mean, there's a guy with his little pellets in the shoe and so on. But as I said, at the bottom of it, you have to repatriate the gold into the legal chain, and that comes into these small-scale pawnbrokers and the refineries, and a lot of the profit is actually in VAT theft. These are old estimates. They estimated about 4 billion rands worth of lost material in 2007. It's calculated things like mine call factors on the rate of seizures, so it's variable. And this supports a fairly massive criminal industry. Okay, so let's get back onto science and why on earth they needed a geologist to help here. The gold material, native gold and processed gold is not pure. It's always going to have a certain amount of other materials in there: silver, copper, lead, mercury, bismuth. Some of this probably relates back to the original formation of the gold, and I'm not going to particularly talk about that because there are lots of arguments. The gold we extract out of the Wits gold centers, the so-called gold, is between 60 and 90% pure gold. The rest is made up of other materials. There's plenty of, I'll show you as it goes, lots of platinum, palladium, iridium, rhodium, iron. Many other things are actually in that gold already. And obviously we remove those through electrowinning and smelting and other processes around refineries. But the basic idea of gold fingerprinting and forensic tracking of this is that the particles, the gold, has a particular chemical profile which we should be able to link from the stolen material back to the original mine where they came from. Well, at least that was the idea. Now, this is something that's been done in other ways. A lot of work was done on automotive glass. Amazingly enough, apparently every company that makes glass, sheet glass and things, has its own combination of things. And in many places, Australia, the US, and South Africa as well, apparently, I'm using the word apparently, it's been proven in court, you can definitely link glass from an accident scene to the place that makes it, and often to a particular brand of car. And of course, if you have a car that you suspect, then you can match the glass directly, all right? And this is done with a laser ablation, ICP-MS, and you either have a database or you do a direct comparison. They also match paint. Paint can be matched very easily. And similarly, apparently, I've never done near this. Nobody lets me near old masters. The forged paintings can be, the paint from that can also be identified. Okay, so when I got there, I was hired in there to prove that we could use the gold fingerprinting process to actually repatriate stolen gold. So the gold is seized. You've raided a place and you see 20 kilograms of gold. You would like that gold to come back to its owner. Well, the mining company would like its gold back. But how do we prove and how do we make that link? And so this was one of the primary driving things, was to actually return that, because that is profit that should be returned. So when I started, we were using a laser ablation setup and a high-speed time of flight ICBMS, very cantankerous, but we were able to sample 260 elements in every 40 milliseconds, right? So there's a very fancy machine. Later on, we moved to using a more normal ICBMS setup, but as the ICBMSs got better and better and had things like collision cells and everything else, we were able to move away from the time of flight machines, which were very, very cantankerous. And I mainly worked with 60 different elements. So that's a very big multivariate database. We were doing this because Roger had somehow convinced the government to write a bit of legislation that said all sorts of mining material must be given to the police in order to be fingerprinted for the future. So all the producers are supposed to provide samples regularly. I'm not sure what's happening now, but we always had a big problem with actually enforcing that there. Okay. So there's a little bit of what we're looking at. There's some gold. There's a couple of holes of different sizes drilled into gold. And there's a look at what the laser does. Okay. You put your sample in there in an argon gas, and then you zap it with a laser, and then you take the material out. When I was with ARL, we were using a 1066 nanometer laser, which used to blow enormous holes in everything. But a couple of years later, I was using a much more refined laser, which produced much less scatter. And that is one of those improvements that allowed us to do a little bit more work. There again, if you don't know what a ICBMS looks like, that's basically it. It's a reduction coupled plasma, torch at one end, and then either a quadrupole or a time of flight set of detectors behind that. Right. What I'm going to present now is some of the data. There are other ways I could have presented it, but this is what I actually used in the court documents, which we published. And I just want to note that it is advised to keep the level of mathematics in a court document to the minimum. All right. And so a lot of the work I did, I used multivariate statistics, cluster analysis, principal component analysis, anything else to identify the analytes of interest. And then I used a set of more simple diagrams in order to present it to the court. One of the things I did realize is that most of the time, my reports on the gold went through without questioning. The lawyers from both sides never questioned anything about it. All right. They would question anything about whether or not you had a proper certificate for the entry and exit gates on the labs, whether or not there had been, you had updated and had up-to-date fire extinguishers, whether or not you had actually relevance in your degree or anything else, but very rarely do they actually test the data. They'd rather discredit the man than actually try to understand the data. But you've still got to explain the data to the judge in South Africa. Fortunately, around here, you don't have to explain it to a jury as well, which I'm told makes it even more difficult in the States and places like that. Okay, so what do we find? All right. So when I started out there, I started looking at different things. So this shows you a mixture of legal sources of gold. Gold is sold as a set of alloys between gold and copper. All right, we remove the silver, sold separately. So if you buy 9-carat gold, it is going to be, as you see there, about 38% gold, and everything else is going to be a mixture of predominantly copper. You see the 14-carat isn't very common, 18-carat's more common there, and down at the bottom there. So the little green squares are the legally available alloys from brand refineries. The blue squares are jewelry that was seized from a number of places that was believed to be normal jewelry. Some of that was also, don't tell anybody's wives, but a lot of the guys used to put gold rings, wedding rings under the laser and zap them because it was fun. So it builds up the number of data. Because you just rub your finger over it and the spot's immediately gone, right? So we put as much in there, and then the black shows you what the mine gold, the bullion, looks like. See that the mine gold is very, very gold rich. Yeah. And this is what we get when we start to add suspect material in. You see that in this one, the red material plots over a much wider area. So originally, this is how the process started. The idea was, could you just identify the gold, whether or not it was a legal alloy? But there was enough scatter amongst the blue to realize that that wasn't necessarily going to work. And so we started to get fancier. All right. This is gold, zinc, and copper. Look at it. Zinc and copper, well, copper is found in gold, but zinc isn't particularly. But we found that a lot of the stolen material was actually it conforms with stolen the ratio of copper to zinc in stolen brazing rods. So you always used to find, if you did a raid, you find lots of brazing rods, and you could see them sticking out of the melting pot. And so they would remember, you're a criminal. You don't want to spend money on anything. So you're going to steal the brazing rods. You're going to steal copper fittings. You're going to steal copper wire to mix in with your gold. Right? So there's the copper wire trend over there. But here's the brazing rod line over there. You can see that some of the jewelry plots in other places, but you can see these trends there. But we can continue getting a little bit fancier. There is adding, changing things around a little bit to look at where the bullion plots on this diagram. And here's my principal component analysis, which basically says that you can divide everything into 3 categories: copper and brazing rods, jewelry alloys, and mine bullion. Yeah, very nice 3-component setup. And that, of course, is all the suspect material. All right. So at the end of this portion of the work, we were able to distinguish between the gold, legal gold, and illegal gold. The legal gold does not have mercury, lead, bismuth, and a whole lot of these things, most likely because it's not smelted at low temperatures with a blowtorch. Your legal gold's all gone through copper in pulp. I mean, not copper in pulp, carbon in pulp. There with cyanidation and activated carbon. And so that's how they make the gold there. That gold has no lead or mercury, no thallium, no bismuth, nothing that is going to be nasty, all right? Whereas the gold we were picking up there, you could basically use your handheld XRF and you could spot which bits of gold were illegal. However, in the broader thing about repatriating the gold, this is some diagrams here. You can see the Wits gold is all in red. I had samples from Ghana, there and there. We had a couple of samples from Murchison and other areas. So on the principal components, you can see that we've got a very wide range of compositions amongst the Wits gold. I was also able to identify some places very easily. For instance, Vaal Reefs. Anything from the Vaal Reefs area has got high nickel. Comes out straight away. You can see that's everything else over here, and then all the high nickel material there. So if I find high nickel in something, it's very easy to place it back to a particular area. But in areas like Free State, we don't have a very clear separation, a lot of overlap. And here is from the best Wits area. You see that we've got a certain amount. I think some of these areas don't have a lot of data points. And when I left police ages ago, they were working to try to fill in these areas, and so on. But we found the biggest problem was that because we're dealing with two different methods, we couldn't clearly identify necessarily where gold came from. Obviously, if you seized gold on a certain mine property, you have another leg of evidence, and then of course I can do a direct comparison. But if, for instance, the seizure was done out there somewhere in City Deep where they're processing it, I am going to struggle to place it directly to a reef, because what I'm getting out is going to be full of lead and mercury and bismuth. It's going to have different ratios. And unless it's got a higher degree of nickel, I'm not necessarily going to place it back. So when I left, we had worked to move on to other things. And recent conversation says they have moved on to using things like stable isotopes. And there are major stable isotope differences between the different areas. However, that data has not yet been released, so I can't show it around. I keep on asking for them to give it to me, but nobody ever gives it to me.
What isotopes are?
You can use it on the lead isotopes. You can use it on thallium. You can use it on uranium. Apparently, there's a big variation in uranium and thorium there. But there are others that they've pulled out as well. And as that goes, that would be very interesting to see, but I don't have that data. Along the way, we did do lots of other things. We might have cut gold theft in half without trying anything. So this is an example of picking up other things while you're doing this sort of work. So we went and we wanted to get the prills. If you're familiar with gold mining, the way they survey, every day they go down, and once a week they survey a face, they get it scrapings off the face, and they used gold assay techniques, the whole China dish and the flux and everything else, and they produce what's called a prill. And so every face has got readings along that and different categories to tell you exactly where the gold value is and so on. And we were interested to see whether or not we could not use the gold prills to get around the problem of processing. So we asked a certain gold mining company, could we have all their prills? And this comes into a fair whack. I got 3 big vials of gold, all the prills. Unfortunately, what we'd have preferred was to be able to link it back to a particular stope and a particular date, but we got a month's worth of production each. So it comes from the carbon leader, the VCR, and the main reef, which at least we did get. And there's a very young me from the back there. And what I did, I mounted all of those gold prills on a small stop, and then I stuck them under the laser and I zapped them all, looking to work out the profile. We used glass standards to calibrate, which can obviously be improved, but we found a lot of problems with trying to get a matrix match standard. So we went for the glass NIST standards as there, and they work well for most things except for gold. All right. So we measured gold by difference, and we were able to go down to low ppbs and sometimes even ppts. Okay. And this is sort of what we started to find. So this is the content, the gold content of the prills from the carbon leader versus the VCR. And you can see that there's a change in there, in those. And you can also look at other contents. For instance, the silver content is slightly different, but especially the platinum and palladium content is quite different. You can see that the platinum profile is very different to the palladium. The platinum profile from the VCR and carbon leader are very different. All well and good, but what we also stumbled on was this. almost 30% of the prills we sampled actually still had significant lead in them. All right, up to 50%. They also had bismuth, mercury, and thallium. Now, the problem with this is that a fire assay is supposed to remove all the volatile elements. You flux it, you use the collector, the lead collector in there, you then put it in an oven for X amount of minutes at a certain temperature, and what you get out is supposed to have no volatiles. And this is what I'm pulling out. All right. So we had a good look at this, and we basically worked out that the prills were effectively overweight. So if my prill is 50% lead and 50% gold, and I believe that's all gold, because they didn't, on the mines, and they still do it to many mines, they simply weigh the prill and apply a split, which they have worked out for silver and gold. They don't analyze them. So they would never have picked up the fact that they had overweight prills unless we had done this whole business. All right. So effectively, they were overvaluing their products there. Once we'd reported this, and I think this was mainly, they used very large ovens with a thermocouple in the middle. So they don't necessarily know that the whole oven is actually uniform in temperature. So we suggested that they go back and they use the ICP OESs and the MSs they had for water sampling, because the mines were already sampling a lot of water samples for environmental reasons. And the mine, the company we're in, 6 months later issued a warning and devalued their entire South African gold reserves by a fair chunk. And that is because they were actually measuring overweight prills. So of course, because that was the difference between the mine call factor, you've got the gold prills versus which is what they expect versus what they actually get out at the end of the mining process. That's your mine call factor. Because they no longer expected as much, I've reduced the mine call factor. And of course, because the portion of the mine call factor is supposed to be theft, we might have reduced theft. So again, this is very wide-ranging thought. We're doing things, we came across this sort of thing by accident, and we looked at that sort of thing. All right, moving on to other storytelling, other forms of mining theft that we worked in. Platinum's a different game, all right? A certain amount of platinum material did come through the police labs, but it comes through in a very different source. Whereas if you go into the safe, you're going to find everything from little gold bars to fake jewelry rings to necklaces to odd plates and bits and pieces. Platinum is stolen in the form of concentrate in the main. There is, if you're lucky, I've got 10 ppb per ton at the top of PGEs there. It's lower than that in most places, all right? It's simply not worth going underground and trying to steal the raw ore. You just can't move enough ore and you can't process it enough to get it out. So instead, they generally try to steal the concentrate. Some of it's stolen off the plants, and there's various ways to do it. You can dip your jersey in the froth flotation tanks and just pull it out. You can, there's stories about how they used to, the plumbers used to come in and fix clogged pipes in the showers, and the U-bend underneath would have mercury in it, and they'll actually concentrate it that way with everything that washes off, and things like that. But a lot of it,
the grade of platinum was about the same as gold. 10 grams per ton is a good gold ore and a good platinum. No,
not really.
why am I going on?
There's a lot less of that, and the other things is there's lots of copper and nickel in there, but no, it's not there, and it's total PGMs plus gold is what's normally reported.
So you have talking about billion, not PGM.
Yeah, I think I'm looking at that as well and going, that looks like an error.
That's it.
Yeah, but there's just Mogalakwena is running at less than 2 grams per ton at the moment of all PGMs. and some of the mines are running at 0.5 grams per ton. Yes, I am wrong there. Should have spotted that one.
That's what I'm here for.
Yeah. So the concentrate is up, and again, that looks as though I'm an error of an order of magnitude out on the concentrate.
I don't think you can say ppm per ton, because ppm is already
It's
a
a,
weight.
yeah,
It's wrong.
you are correct.
It's correct.
I should know that. Yeah. Okay.
Good job.
Yeah. Yeah, that's the thing. I need to remove the per ton there, because that's where I'm getting wrong. I am probably right at 10 ppb, but that's not per ton. That's already per unit. All right. Okay. But anyway, as I say, it's stolen as concentrate. Often it's stolen. It's an intelligence failure or a security failure. 13 bags go on the truck. 12 bags are logged as it leaves. 12 bags arrive at the other side. The 13th bag has disappeared. All right. So we did not. What we often had to do for PGEs was actually to prove that it was PGE material. So we had to provide a value estimate, because in our legal system, the value of the stolen material, of course, determines the size of your prison sentence. So a lot of the work we were doing for the PGEs was simply to evaluate that. So we simply had to work out how much was there. Yeah. And there, one of the things that happens with that is that in South Africa, there are only a few refineries that you can go to. But there are refineries in Switzerland which take PGE concentrates from various sources, because a lot of mines don't mine the PGEs directly. They mine in copper and nickel and produce a small amount of material as a secondary point. There's PGEs being produced out of the copper belt, the Zambian copper belt. They're being produced out of other mines all through Africa. And that final concentrate that remains from those mines is often sent to Switzerland for processing. All right. And what we had a lot of problems with was obviously forged certificates of origin. So there was plenty of South African material being sent up to Switzerland, but it's very, very hard to prove. And that was there. Okay. Let's say lots and lots of stories from the plants. The concentrate comes out looking like a black or gray material. It's fine. It's there. Sometimes it's actually transported in a semi-wet state as well. So it's basically mud. And it's, if you've seen it, it's sometimes hard to believe that that's actually where all the material and the value is. Right. And unlike the sulfides and the gold, which has a distinctive color, the concentrate here does not. And so this material will be picked up. Often they'd have a raid on a pawnbroker, and they'd seize all the gold material, and then there'd be several bags of other material, which you'd sample and go, well, oh, this is platinum bearing. Oh, this is dirt. I'm pretty sure some of the syndicates and the pawnbrokers passed off other material as PGE bearing like anything else. So you'd find that and you'd have to value it in there. Okay, we also worked with diamond theft occasionally. This was something De Beers and Mentec were mainly in charge of. And diamonds, again, are sold in different ways. You wait until you can actually remove the diamonds they have to find the diamonds and pick them out before you can actually do it. So if a worker spots a diamond on a conveyor belt or is working along the beach and spots a diamond, that diamond will be picked up and either handed in or secreted somewhere. And again, a lot of this was a security issue. As it says, pigeons flying across the border, fences in Namibia, body cavities. Yes, how many times are you going to get a full body cavity search? Every so often somebody does, but might be your day, it might not be, right? Bribing the security guards, always. So lots and lots of different ways. Bags thrown over the fence to be collected at another time. And all of that comes in there. Interesting enough, you can see there's a picture from over here from the early days in Kimberley where they were looking at that. So this has been a problem for years. Over there, they look, generally, diamonds themselves were not terribly useful to target and analyze, but the inclusions are distinctive. The only problem is you actually have to drill a hole into your diamond to actually get to the inclusions. So it's a little bit more destructive than some things. One thing else we'd also worked on was chromite. This was one where occasionally you get asked, can I get the chromite back to where it came from? This causes a lot of hassles because to a certain extent, unlike in the other places where a lot of money has been spent to open up a mine, to process the material and everything else, many times these miners for chromite are mining an area which has got no fences, no security, nothing done on it, and so they're simply removing raw ore, which somebody else has a mining license to it. So it's very controversial, all right? But I can tell you that there is quite a lot of, there are numerous ways to tell which of the different chromite seams that it come from. Obviously, each of the different chromite seams has a different iron to chromium to PGE ratio. So you can normally tell which seam they're mining from. And you can also tell whether they're mining from the north, the far north of the eastern limb. You can tell that whether they're coming out of the western limb. The chromite does vary significantly between different areas. So if you sample it, you can trace it back to a particular seam in a particular area of the bushveld, but you can't necessarily trace it back to a particular area necessarily. Again, there's a Zamazama coming out there. Other cases I've worked on, many of these come up through word of mouth, and somebody asked there. SARS has asked me to comment on coal royalties, which basically means they're interested in knowing about what the value of the product actually is, because the mining companies obviously claim that they are paying a certain amount of royalties, and they're claiming that this is the material and the quality of the material they're sampling. I don't know whether some of you have actually ever worked with coal. Coal is an incredibly difficult material to characterize. It's generally characterized pretty much by bucket chemistry. You take the sample, you weigh it, you stick it in an oven, you dehydrate it, then you put it up higher degree with nitrogen rich. You combust it there to work out how much volatiles are there, and then you weigh the end of the silica in. It's very variable. But you're still able to work, even though it is variable, you can often pick up when there is a clear discrepancy between what is claimed by the mines and what they should have. And so that work is done when somebody from SARS comes and visits me. Right? Other things I've done, radioactive and hazardous waste, the dumping of uranium-bearing, actually, I'd say all on mine dumps and other places, hazardous waste coming through there. One of the things I've had to look at is through a whole lot of XRD data and trying to distinguish between what should be in a mine dump and what shouldn't be in a mine dump. And strangely enough, I've never yet landed up in court, which again, as I said, a lot of times these big cases are settled out of court. There was an article in the Daily Maverick last year referring to the finalization of a case I worked on back in 2006. When I was working on there, because of the complexity and the fact that the opposition has a lot of money, all right, these court cases will literally drag on for decades. So at the time, we did a lot of work with the Scorpions, and the Scorpions always had a SARS attacks investigator with them. And SARS, if you don't know them, has the right to levy a fine on you and then ask you pay up and then come try to explain and argue the fact afterwards. Right? And so the case we were working on there, as it went through, eventually there was an agreement and a massive amount of money was paid over for, effectively for tax fraud. But the case at the bottom end of the case was that they were buying stolen gold. But in order to prove that it's stolen gold, you have to jump through a lot of hoops. Did they know it was stolen? Did they buy in good faith? X, Y, and Z. And if you've got a lot of money for your lawyers, as we might know about certain ex-politicians, you can definitely lead on these cases for a very long time, right? And again, a lot of times the report is actually accepted without any argument, but the argument is go on to other factors. So it's a different game. But yeah, that's just some stories mostly. There's obviously a little bit more science behind it, but at the bottom end of it is analyzing material, looking at the analytes, and trying to assess and match them to either a database or to a comparison sample. Same thing goes if I was to work with mud, where the principle normally is to dissolve the sample in water and look at the amount of vegetation, the different types of sediment in it, and compare it there, which I have to say, when you walked into a lab and all you have is these little beakers full of mud being separated in centrifuges, it looks a little bit like witchcraft. Okay, so that's some thoughts from my side about things. I've got plenty of other things I can say and things I probably shouldn't say, depending on what you ask me. But I hope that's what Jill asked me to talk about, and hopefully you've learned a little bit about things, even if you probably haven't learned an awful lot about chemistry. Okay. Pleasure. There is a comment there about my ppm and the ppb situations there, and so on.
Is that a curiosity?
Yeah.
Would you like to come and speak on the microscope? Oh, microphone? Yeah, come forward. Please come forward, because otherwise they cannot hear you.
Yeah. Don't worry, they can't see who you are.
Thank you for the great talk. I just wanted to know, you said that you compare the legal and illegal gold. So I'm guessing the illegal gold is the one that it's from the Zamazamas. So when you compare it with the legal gold, do you have data from all the gold mines in South Africa, and you compare it with what they have to figure out where it's what it's related to? Or how do you go about trying to verify where the gold is specifically mined from?
All right. So we have a big collection of, so the question was how we go about it. But we have a big database of gold material from all the mines. So we do have all the legal gold. We also have Rand Refineries samples. Rand Refineries were sending us a new set of samples every 6 months. And what we do is zap the material, the unknown material, suspect material, and compare it to either to the database, or we'd look at the trace directly on there. For instance, whether it's illegal or legal, we can tell immediately that if you've got the lead and the mercury and the thallium, it's not produced by a carbon impulse producer. And there is no mining house in this country that has used something like lead collection or so on for many, many years. So we know we can do that. But the rest is comparing it to the database of samples we have. Yeah.
Are the samples that is always updated by the mines, or it's just old data?
the mine's supposed to send new samples every 6 months, and it depends on the mining house whether or not they do. All right, and enforcement is a big issue. The regulator does not have a lot of people involved in it. The police are massively under resourced, and so I would say that we don't have completely regular updates. However, I have time-graded data which shows that there is not a lot of variation from the different mines. If you know which reefs they're mining, you can clearly see, and the individual reefs are very consistent, right? So that doesn't happen. But if you have a new producer who isn't on the database, that might consider a problem. However, they will still be using carbon in pulp, which is very important because the carbon in pulp is going to remove all those traces of low temperature volatilization. Okay.
Thank you.
Yeah.
Thank you, everybody. Thank you, James, for visiting us today.
Pleasure.
This concludes the Geotalks for this year. We are going to enter into a break and we will start again from the beginning of February. So if any of you wanted to come and present, or you have an idea of a speaker to invite, please let us know. And I thank you, everybody. Bye. Exactly. Very disturbing.